Good evening, Mass. I'm not sure if we have any man in our midst. Okay, good evening, Mass. Good afternoon, good evening from anywhere we are joining from. My name is Cecilia Adenusi. I'll be a moderator for today's event. So thank you so much for joining us. We want to appreciate every one of us. I can see Adeola Lawal. I can see Madam Ayodele. I can see Kamadin Hayodele. Thank you so much for joining us. I can cite Khadija Temitok, thank you so much for joining us, Ma. I can cite our presenter, Kayat Olakbojoye. Thank you so much. I can cite our mama in the house, Mama Dr. Shekinat. Thank you so much. And I can cite Shatil Tahil. Apologies for not pronouncing it properly. Thank you so much for joining us. And I can cite the Thomas Adewumi University. Maybe that's our prof. Thank you so much for joining us, everyone. So we are starting today's event. We promise to comment 6. We want to keep to time. So thank you so much, everyone, for joining us. So we welcome everyone once again to our May webinar titled Revolutionizing AI with Federated Learning, which will be diving into the privacy, the collaboration, and the future of decentralization, decentralized intelligence. So before our speaker will commence, we'll quickly call on to we want to appreciate our host, Madam Sekinat. Dr. Sekinat, thank you so much. Let's appreciate our host for allowing us to host this kind of event. Thank you so much, Mama, for always backing us up, for always giving us go ahead. Thank you so much, Ma. Thank you, thank you, thank you. We appreciate you. Okay, so I want to proceed to the next one as I welcome Madam Adiola.
Okay, good evening, everyone, and welcome to the May series from the Women in AI Nigeria. We want to say a big thank you for joining us. In Women in AI Nigeria, we are here to support ourselves, here to learn. The unity is important to us, and we want us to keep to that. Thank you all for joining, and we hope to add more series coming along. So join us as we go on. And if you want to join the community, please message us on LinkedIn, and we'll definitely get you across to join the community. Thank you, everyone, and enjoy your evening. Please go ahead. Back to you, Cecilia.
Okay, thank you so much, Diola. So that's a short summary of what we have. If you are just joining us for the first time, we are Women in AI Nigeria. Okay, so that is who we are. So if you want to join us, follow us on our LinkedIn, send us a message, or add it on our LinkedIn. But on our page, we are women, so it's women that can join our platform. But any guys are free to join any of our webinar and engage with us. Okay, so let's proceed to the next one as I welcome Madam Sumilawa. Sumilawa, are you with us? Sumilawa, are you with us?
No, please just go ahead.
Okay, if she's not with us, what she wants to tell us about is about membership. We want to encourage more women to join us in Women in AI. We still need more hands. We also need a volunteer. You are skillful in a particular aspect. You want to join us to promote, to push this community forward. We are open to volunteers. Okay, you can design, you can anchor a program, you can help us in membership driving and different aspects that we do, workshop planning and the likes, online engagement. You want to help us to engage on our LinkedIn, on our Twitter. We actually need more hands, so you can volunteer. So you can volunteer for us to volunteers to hostel. Okay. So thank you so much. So you can signify and reach out to us. We want to specially welcome our guest speaker before we move to the next item. So want to appreciate our guest speaker for joining us all the way from United States of America. Thank you, thank you, thank you, thank you. We love you. Let's throw a beautiful emoji even before we read our citation. Thank you, thank you, thank you, thank you, thank you, thank you for welcoming us, for accepting our invite, even within a very short time. Thank you, thank you, thank you, thank you. Okay, so our membership link is being dropped on the chat board, so we can make use of it. And on the chat board, so we can introduce ourselves. I'm joining from Nigeria. I'm joining from Australia. I'm joining from Europe. Let's drop our information to, let's drop our LinkedIn. We can use this opportunity to also follow one another on the chat box. Introduce yourself, drop your LinkedIn so we can also follow. So in a gathering like this is a way of also networking with one another also. So you can drop your LinkedIn on the chat box. We can follow ourselves. Just tell us the summary of who you are, where you are joining us from there. We can also follow. So thank you so much. Let's make use of chatbot to do that. Let's make use of chatbot to do that. So quickly go into the next thing on the agenda. I don't know if Madam Mayodele is with us. Do we have Madam Mayodele on the call? Okay, I can cite Aminat Farm joining from Lagos, Nigeria. Thank you, thank you. So you can also add your LinkedIn profile so that we can go ahead, so that we can join you, connect with you. Let's connect with ourselves. We are all women or men AI. So we can also connect to ourselves. Okay, I think Madam Ayodele is having a network issue. So I will just quickly brief us on what she wants to talk on. She wants to tell us we have something planning, we have something fresh planning for us, woman in AI. We have something fresh for us. We are planning an online workshop, but we don't want it to be a usual workshop. Okay, that we actually want to tailor the workshop to our need. So I want us to make use of chatbot. What do you love to learn? What do you love to learn in the next 1 month, 2 months? Yes, I want to know more about federated learning. I want to learn more about AI agents. I want to learn more about reinforcement learning. I want to learn more about deep learning. Or I'm interested in any type of models you are interested in to learn. We want you to drop it. Drop it on the chat board. Let's make use of the chat board. What is that particular model you are interested in? You are working on a research work. You need this particular model to be able to implement. You love to learn it yourself. That is why we are here for you. So drop it on the chat board. We can actually use all these requests to tailor our workshop. We don't just want to organize a workshop, pick a topic randomly. The essence of the workshop is to serve us, meet us at that very particular needs we're actually looking for. You are working on a research work, we are working on a paper, or you are looking into knowing this. You already knew this, you want to know this. Please drop it on the chat box with us. Just drop it. I'm interested in AI agents. I'm interested in reinforcement learning. I'm interested to know more about this federated learning we want to talk about today. Or I just want to know more about deep learning. Or I just want to know more about machine learning generally. I want to know more about natural language processing. I want to know more about, I want you to be actually specific. Be specific with what you actually want us to treat and our forthcoming webinar, so that once we release the flyer, you already know the track you belongs to, because it's going to have different track. Okay, this is my track, and I will follow you through to the end. You don't have to do natural language processing today. Tomorrow you want to go and do AI agent. Next tomorrow you are doing reinforcement learning. We don't want that. Okay, so that you can actually identify your track, then you stick to your track. So we would love to hear from us. We would love to hear opinion. Please, let's make use of the chat board. Please, Adiola, as they drop it, help us to pick those information so that we can collect it together. So thank you. If you are just joining us, this is Womwn in AI, our May edition today. So we will be starting. And we'll be calling on our amazing resource person. We'll be calling all the way. Now I'm in Nigeria. I'm taking a flight from Nigeria at the moment, and I'm flying first class. I'm in a first class plane, and I'm flying to the United States of America. Yes, I am here with the resource person. We have, okay, let me try and share. Okay, let me share. Let me just read out. Okay, so I'm just here to introduce. Welcome with me. Let's with a beautiful emoji as we call on our resource person today. As we call on Rukayat Olapojoye, which is she's a dedicated IT professional and a doctoral research at Texas Tech University in USA. She specializes in blockchain technology, federated learning, security, and privacy of decentralized system. She holds both bachelor and master degree in computer science from the University of Ibadan, Nigeria in 2014 and 2018 respectively. She's a very active member of IEEE, Women in Engineering, IEEE Communication Society, and other IEEE community. Rukayat has received a notable recognition, including the 2023 Google Computer Science Research Mentors Program and 2022 Women Tester Fellowship. She has published in leading IEEE conference in AI, security, data privacy, and served as a reviewer for events such as IEEE and many more. So welcome with me as we roll the drum with beautiful emoji. Madam Rukayat. Thank you so much. You have the floor, ma. You're welcome.
Good evening, good morning, everyone, depending on your time zone. Thank you so much for having me, and I feel so honored to be taking us through a very interesting topic today. Thanks for the interesting introduction, Madam Cecilia. I really appreciate that. So let me know when you want me to start the presentation. Are we still waiting for more people to join, or we could just start right away? Okay, so I'll be sharing my screen. Could you please allow me to be able to share my screen? Okay, thank you. Can you see my screen, and could you please confirm, am I audible enough? Can anyone hear me, please?
Yes, we can. Yes, we
Okay.
can. You can see your screen. You are audible.
Okay, thank you. So I've been introduced, and my name is Rukayat Olapojoye, and I'm a doctoral researcher at Texas Tech University, majoring in computer science. So today we will be talking about a very interesting topic, revolutionizing AI with federated learning. We'll be looking at the privacy, the collaboration aspect of it, and the future of decentralized intelligence. So to begin with, I do not want to assume we all here are AI experts. So I would like to briefly introduce AI. So just to outline my my course of discussion. So we'll be looking at the evolution from centralized to decentralized AI. We'd also be looking at the history of the hot topic, and that's the history of the federated learning system, and we'd look at the overview of it, like the process, the application, where areas where we could apply this paradigm, then top companies that are presently adopting it. We'll further look at the challenges it actually has in the implementation part. Then the future of decentralized intelligence is something we'd also look at. We'll give room for questions and answers. So just like I said, I do not want to assume we are all AI experts. So just like as a refresher, what is AI? Basically, AI is simulating human intelligence. That's our own intelligence with machines, making them able to learn, to reason, and to make, good decisions like we should be able to do. So, what are the core areas of AI? Some of us might be aware of this. Some of us are experts in AI, just as a refresher. So, we have what we all talk about, machine learning, machine learning, machine learning. Yes, it's a very core aspect of AI. And what does it do? It basically, we want to learn from data. AI is based on data. There is no AI without data. So we want to learn from more data to improve our AI models. We also have the NLP, which is also a hot area of AI. Basically, what this helps us do is to understand and interpret our languages. We want to know more about like our languages and be able to interpret them to a machine. Computer vision is another core area of AI. What this does is helping us understand the visual information from our images. And we also have the robotics, creating robots to interact with us, to interact with the world generally. We have cleaner, we have some um, you know um, robots that could help us to clean. Some could help us to serve at parties. In fact, currently people are coming up with doctor with like AI solutions that would allow a robot to operate on patient. I would not allow a robot operate on me anyway for now, but these are things that AI have been helping us to come up with lately. So what are the areas, the major areas where we can apply AI? Healthcare. This is a general platform or sector where we see AI booming. Basically, we use AI in the healthcare majorly for diagnosis of ailments, and there has been a rise for that in my part of the world, and I think in most part of the world now, where we see AI based, cancer, these AI based diabetics, system, yeah, things like that. We also have AI, the rise of AI in autonomous vehicles. We have self-driving cars now, for example, Tesla and other self-driving cars. And these are actually on the rise. In fact, in my part of the world, I stopped, I couldn't count how many new Teslas I see on the road because people are enjoying the ease that comes with the self-driving cars, although they also pose their own risk. Anyway, we have the personal AI um, um, assistants like the Siri for those that use the iPhone. We have Siri to say, "Hey Siri, call my mom. Hey Siri, text my friend. Hey Siri, find my car keys," things like that. So these are the things we benefit from AI. And also in cybersecurity, AI could help us detect cyber threat. Now, from the main, this is just like a refresher to bring us all to the table of what we benefit from AI and the core areas of AI where we really use AI. Most of us use more of AI in our day-to-day life now. So how are these AI, the AI systems we kind of use, how are they trained? Let's look at the journey from centralized AI, where we have to transfer data for us to, create AI models. But this, approach doesn't allow much of collaboration. And that is where the problem lies. And the fact that we have to transfer data, we lose our privacy, and also the collaboration is also not, so encouraged. Now, let's see what the traditional approach is like, that's the centralized AI system. So basically, um, in a centralized AI system, we need a central server. And why we need that is to process maybe like our data, and we need it for computation because AI is all about data, and data is all about, we have to compute things, we have to generate algorithms, we have to, do a lot of stuff with our AI models. And we would also require the need of a data center because, like I said, AI is based on data. There is no AI without data. So for this, that means we need to transfer data and store this data in a data center. Additionally, model training is a key part of AI systems, of centralized AI systems. So from simple models like our CNN, our DNN, to complex models like the ResNet, the AlexNet, and so many of that, we would need a central server for that. And we also have this in a centralized AI system. Hyperparameter, whereby we kind of find the optimal value to control the learning process of our models. All these happen in the centralized system. So after all these, what do we need to get? What do we want to get from this? The inference. We want to be able to predict, to predict weather, to predict so many things, and maybe to classify in case, like in healthcare, we want to be able to classify benign tumors from the non-benign ones, things like that. And these are the things we get from AI generally. So, but this system, it's like the centralized system where you have everything, majorly the data in one data center. But having said that, now let's weigh the advantages and disadvantages of the centralized AI system. We could say that the centralized AI system is reliable, yeah, because we have the data, with conforming with standards. We have them in one data, warehouse or data center, and because we have the data together, unification of data is something interesting. We need that because we want to comply with standard. Like we want the data to be like to be clean and things like that. Like but and also for a centralized AI, we require a very high compute power system. And so centralized AI has the liberty of making us work on high compute system. However, there are some disadvantages we most times, or in present time, way more than these advantages. And the first of it is a single point of failure. So what happens when we have all our data in a data center, and where we store our data, maybe there's a power outage or something, or there's a uh as like an attack on the system or something, or our data warehouse is lost, is nowhere to be found. And then some will say that, oh yeah, we could back up in cloud. We depend so much on the cloud, but I mean, something could still happen. There could be cyber attacks on our infrastructures, even in the cloud. Yeah, people are working towards, creating new attacks. Why some people are working towards creating new systems that could, help to defend these attacks. But the simple point of failure is still a very critical part of centralized AI that needs to be looked into. So data transfer costs, because we have to transfer this data from various millions of devices, IoT. So it could be costly. And when we're talking about data, it's not about one gigabyte of data. We are talking about millions, tons of data, millions of terabytes of data. And we need to transfer this data onto a data center. This is a lot of cost. And this could actually discourage people, from participating in, co-training or collaboratively train an AI model. So another very important part of, disadvantage of centralized AI is a privacy risk, because we have to send our private data. We have to send, data of patients from our hospital data infrastructure to a data center. We're exposing these patients, we are exposing their data. We are jeopardizing the privacy of their data. We are bringing them out to the world, and we can't really even trust our servers, or trust our data center, to be honest, all the time. Now, so that takes us to the journey of decentralized AI, whereby we have collaborative framework, and data privacy is encouraged, is ensured in a decentralized system. So basically, what a decentralized system is we need to train an AI model for a particular task, but we want to ensure that we uphold privacy and we encourage collaboration. Basically, we need to collaboratively train a particular model on local devices. So we don't need to harmonize this data. We don't need to transfer this data onto a warehouse. We leave this data on various devices. And so a device doesn't have to be just like our gadget alone. A device could be an hospital data infrastructure, an autonomous data warehouse. As far as you have data, you have a lot of data to participate in training a model, that could be a device. It doesn't have to be. So for simplicity and for us to be able to, get in the facts from this discussion, I'm gonna use like our gadget as illustration. So let's imagine we have a task of improving the voice search functionality of Android, for example, or Android is fine, and we want to train a model for that, but we want to also uphold privacy. What do? We rely on decentralized AI to allow us to be able to train this model on local devices. How these devices need to share with the server is just the local model, which should then be aggregated by the server to get the global model for our task. Having said that, now the question is, should we really implement a decentralized AI system where we could like benefit from the reliability of a centralized AI system? I would leave the answer to us, but we would have some things to discuss about that. Firstly, a decentralized AI system enhances privacy, which is very key. In most part of the world now, privacy is a big deal. The fact that we enjoy, the ease that AI brings to our daily life, and some of us are still like sensitive to how much the part of our life that is online. We don't want every part of our life. We still want some part of us to be private. In as simple as what we type on our phone, as simple as now we have smart wristwatches that could keep track of how many steps you take per day. Some of us might not really want to share this data, but we want to participate in improving these models. So that is why we kind of rely on decentralized AI in this current time. Aside from the privacy benefit, it also reduces the latency required to generate an AI model. Because if you have to train billions of tons, tons of billions of gigabyte, terabyte, billions of data on a server, for example, there is increased latency. But when we look into decentralized AI, the training time that is required, for us to generate like a local model is much more lesser than if we are considering a centralized AI system. So basically, each client they train like a global model on their own devices within short time, other than having all the data centralized in a particular place where we have to, spend more time to, even if we have like GPUs, sophisticated data center or server, for example, there is still gonna be a high, high compute, high training time, because we're talking about more complex models, sophisticated models, training um, them on billions and tons of data, and that would take much time. However, there are some drawbacks. I mean, of course, there are some drawbacks, and one of it is resource constraints. We are going to rely on these devices, these local devices for training, but we have to be sure that they have enough power, enough compute power to be able to process whatever tasks we are assigning them, especially training. When we are talking about complex model, we need a lot of high compute. And sometimes these are local devices might not have that. So we need to be able to equip them to be able to participate in collaborative training of a global model. Another issue could be, how do we coordinate these multiple devices? How do we coordinate them? How do we bring them like to be able to collaboratively, learn, from this data, from that data, and also to be able to, train a model for a particular task. Now, but there is going to be a trade-off. We are going to trade off resource constraints and coordination challenges for privacy, because privacy is a big deal. We do not want all our lives on the W3 or the IoT. We do not, even if we want to participate in training or in improving AI models, we still want some part of our lives private. Now, for example, the GDPR, which is an agency, global agency, to show you how important privacy is, they fined Amazon in 2021 to a sum of 746 million euros because of data privacy violation. Similar to Instagram, they also got a fine of 405 million euros in 2022 because they violated users' data privacy. Now, that brings us, now we've seen how important privacy is, we've seen how important collaborative learning is. And that brings us to the other topic, that's federated learning, and which is a key component of decentralized AI. So what do we know about federated learning? Federated learning was introduced by Google in 2016. And this brilliant guy, Mick Mahans and his team, came up with the idea of federated learning, and they published a paper, Communication Efficient Learning of Deep Networks from Decentralized Data, in 2017. So what was the motive behind this? The motive behind this was a privacy-first AI for mobile apps. Most of us, just type on our devices. We do not really know how they get data to improve this, to improve the efficiency or the functionality of like our keyboard, for example. So Google has a keyboard, they call it the Gboard, which most of the Android have, they have that as their keyboard app. And so they needed to come up with a privacy first, in the sense that we do not want to expose all our users' data to like a data center or in a centralized, scenario before we could improve the efficiency of our Gboard. So what do we do? What did they do rather? They came up with an idea of a privacy-first AI app for the keyboard. So basically, they could actually improve the functionality of the Gboard, or let me say keyboard, without having to get data from billions or trillions of users, having to send what the data their keyboard generates to a particular data center to be able to improve the model that drives the keyboard functionality. So basically, they want to preserve the privacy of users and still be able to give them something good to work with, and to improve the intelligence of their keyboard, to improve the keyboard functions generally, the emojis, things that we do on our keyboard. And now, so having said that, so what is federated learning? Federated learning is simply a machine learning paradigm that is designed to facilitate collaborative training on, decentralized data. We want the data to remain on our device. So we do not want to transfer data. But most importantly, it helps us to provide privacy. So essentially, it's a collation of three main points. We collaboratively learn, and we collaboratively train AI models, but we want our data decentralized, and we also want to ensure privacy. So let me take us through the process of how, the process of implementing a federated learning system. So basically, what we need to start with is we initialize a global model. So basically, when I say a global model, what I basically mean is, when we train like our machine learning, like when we train for a particular task, we all do, we train a model with this, with that. But in a federated learning system, we are still using machine learning, but in a decentralized way. Instead of having our data or in a file like a CSV, or if it's images, we have it like in a folder, is the folder something. This data is decentralized, basically. we are not writing off the concept of machine learning, no, because these clients, they are still going to train this model based on the concept of machine learning. They train the CNN, ResNet, all those models. It's still they're still going to be trained basically. But so when we say a global model, because we're talking about a decentralized system that gives us local models from the local devices. So we have like a global model that integrates all this model. So what the server does is it needs to first set up, an initial model. Initial model could be a new model we want to, generate for a particular AI task, or a pre-trained model we want to improve. The server sets that up without having to know anybody's data, basically, and it distributes this model to the devices that would participate, perhaps in an AI task. We want to build a system to help us diagnose something or to help us predict something, but we need a model for that, right? And so this model is sent to those devices, the distributed or decentralized devices for training. And after the training, they generate what we call a local model, which is then sent to the server for aggregation. Basically, what they send are just like, we call them weight vectors, we call them so many things, gradients, updates, and things like that. But they are not sending the actual data of the client, which is used to generate that model. So we are preserving privacy, and we are also ensuring collaborative training. So once this global model, the local models are sent to the server, and the server aggregates them to get a global model, just like in normal training, whereby we train for several rounds, like 100 rounds, 1,000 rounds. This is still going to happen in the federated learning system. So after the global model is generated, the server then redistributes this global model to these clients for round 2, round 3 to round N until the end of the task. Basically, we do not need, so the server has no knowledge of the data which is used to train a particular model. What the server knows, or what the server has, is just the local weight from the client, and that's like the local model from the client. And the global model, it generates from aggregating these global models from the client. So at this point, I would like to stop to see if I have any questions before I move further.
Okay, well done, Madam Novakayat. I think there's a question asked earlier on the chat. Let me just quickly go through. You can check through if you see it before me. There's somebody that asked one question earlier. Okay, I found it from Fatima Salami. Does AI train locally better than AI train on decentralized system?
So, okay, I think if I get it, it's like saying, does the AI trained in a centralized system, is it better than those trained in a decentralized system, right? Or either way. So when you say better, it could be relative. I mean, I would assume you mean accuracy. Like, do we get the better accuracy? So basically, we get almost the same accuracy with the plus or minus like 0.0000. It's not so significant. So I mean, yeah, it gives almost the same training accuracy, and it's as reliable when you train in a decentralized setting. It's as reliable as training is in a centralized setting, and with the plus of privacy um, preserving technique. Like, we want to preserve the privacy of people's data. We do not want to expose. So that's a plus, and that's why we are encouraging more of decentralized training, because it gives almost the same accuracy with a margin of 0.000, which is not so significant. I hope that answers your question.
Yes, it does. Thank you very much.
Okay, so I would proceed at this point if there are no other questions, or they are being reserved for the end of the training. So now, where can we apply federated learning? Basically, I know that's something we really want to know. It can be applied in everywhere we apply AI, basically, not limited to healthcare, finance, IoT, or automotive devices. I mean, it can be applied where we apply AI. Generally, where we apply AI, is it a personal Siri, the Alexa, those things, or is it the self-driving cars or healthcare? But for better understanding now, for us to have a more enriched discussion, I would like to talk about healthcare and finance because that is like practical to most of us. So in healthcare, for example, imagine like we want to have like um a generalized model or an AI model that could help us personally diagnose disease in patients. And imagine if we have to send all the data of this patient or billions, tons of data to a particular warehouse, a data warehouse, before we could build this model. One major flaw there is the privacy breach. We're breaching the privacy of this patient. So that's why we have federated learning that enables us, preserve our privacy, but still we are still able to arrive at our goal of creating a personalized AI model for detecting diseases in our patient. So for example, just like I said, we want to come up like with an AI system that would predict something a patient maybe like for diagnosis, for example. Hospital A, B, and C do not really need to share the data somewhere before that could happen. What we need to do is to just have our server send an initial global model to these hospitals. I mean, to the data infrastructure of these hospitals. Then they train this model, and then they send back their local updates or their local models to the server for aggregation. So this is how federated learning works in the healthcare basically. And interestingly, sometimes ago, we had like a summary of something, so like a collaborative learning that some hospital did. So I'll quote this. In one of the largest reward federated collaborations, 20 independent hospitals across 5 continents train an AI model for predicting oxygen needs of COVID-19 infected patients. On the average, the hospital saw a 38% improvement in the generalizability and 16% improvement in the model performance by participating in federated learning systems, basically. And this is not my word, this is from NVIDIA. And um, uh, you know, equally in finance, for example, we want to like have an AI model that could help us in fraud, prevention or things like that. We do not need bank A, B, C, D to send all their customers' data onto a data warehouse to be able to, come up with this AI system for this particular task. What we need to do is to have this bank have their data in the data center. We have that in banks already. And we send this model, like a model, an initial model to these banks, they train and they give us back their local model, which the L4 server or the server aggregates to get a global model that would then be distributed to the banks to, carry out their tasks, whatever it is they want to do with the AI model. Also, interestingly, NVIDIA has something for us in this regard. It says credit card networks reduce fraudulent activities and banks employ anti-money laundering initiative. Federated learning increases the data availability to a single bank, which helps address issues such as money laundering activities in correspondent banking. So we do not basically need to, send all this data onto the data center before we can achieve this task with AI. And that leads us to looking at top companies that are adopting AI, that are adopting decentralized AI through the federated learning system now. We know the pioneer, it was pioneered by Google. just like I said, and they introduced FL through their Gbot, like I explained earlier. Apple uses federated learning to enhance Siri. Siri is a personal, like a virtual um assistant, so to speak, because Siri, Alexa, they're like mini devices. I could talk to, hey Siri, find my phone. Hey Alexa, play this music. Hey Alexa, turn off the light. You know, some of us have these in our homes, and Apple enhances the 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 functionalities of this device with federated learning, because we do not basically want to bring together data from different people. No, we're going to breach privacy through that. And Nvidia, which is also a very top company in the tech space, they launched Clara. Clara is like their federated healthcare AI. They use it for diagnosis and things like that. We also have like a pharmaceutical um, coalition of more of 10 companies. They use the FL system to collaboratively bring discover new drugs, basically, because they do not want to share private details of symptoms when they use it, like a particular drug, or their clinical trials on drugs. They do not really want to share with other companies, or bring it together, but they can still collaboratively develop models for discovering new drugs without having to share data, basically. Alexa, just like Siri, it's by Amazon. It does almost something like Siri. You know, they use they use like the FL system to improve the personalization of these apps, just for us to be able to enjoy them without having to put our data where we do not want it to be. So we also have like the Roche. They have like a cancer research center, and they've been able to, enhance their findings with the federated learning system, basically, without having to share cancer patient data, or they are able to do this in a decentralized way, with the aim of what, preserving privacy while still encouraging collaborative learning. Now, there are some tools that are, on the rise for integrating the FL in our AI training. So basically, we have tools like Leave, TensorFlow Federated, Flower, PySieve. So now that the decentralized AI is becoming, it's basically on the rise, it's becoming more popular. Many researchers are coming up with different tools, with so many interesting functionalities, even as simple as simulating millions of clients. You do not really need to, try to get data on different, in different data center, or different phones or tablet for you to train. So they kind of simulate a real life scenario of a federated learning system. And so these are good tools or frameworks that we could actually explore to see how a decentralized AI training, I mean, how it really works, interestingly. And just like I said, it doesn't override or take away our normal training expertise of how we train our CNN, DNN, our ResNet. No, we still have that, because each client have to train a machine learning model, basically, but in a decentralized way. So these are good tools. For me, I use Flower because Flower is so user friendly. It's so easy to use. You could use Flower with different data set and different settings. In fact, even on like in a mobile setting, you want to train something for like your like an app on our mobile phones. Flower is very user friendly. I am not paid for advertisement. I'm just like saying this is what I use, and it's so easy to use. And so, but there are lots of frameworks that we could actually explore to learn this new technique. And now I have talked about how important federated learning is, decentralized learning, how interesting it is, basically. But we still have to talk about some of the challenges we face when utilizing this paradigm, when implementing this system. So there are four major challenges that um, we kind of identify in our like in the research page generally, because some of these challenges, these companies that have implemented or integrated the decentralized system in their technologies might not or may not face these challenges because they have all the high compute servers and things like that. But generally, these are the challenges we face. Heterogeneity, because we have diverse devices, we have different kind of data, basically. Honestly, that's why we have something like called the non-IID data. That's the non independently identical distributed data. Simply say imbalanced data. The data is not balanced, basically, because one data, for example, some of the data set we use to test the system, we have like the fashion MNIST that have different classes. But what if someone has a lot of data that the classes are not the same as the other? So that is one major problem of a decentralized AI system. Basically, non-IID dataset, diverse devices could bring issues with heterogeneity of data. Now, the communication costs, like I said, if we have to train, we have to depend on local devices for training our machine learning models. We need to ensure that those devices have high compute power. They have high compute power. And also, because those devices we still send their local model weight, not the local data now, the local model weight to a server for aggregation. We have to also keep in mind that there will be a cost of the bandwidth we would use to send this weight, but they are not as expensive as having to send data, raw data, things like that to the server. So scalability, how is it possible for us to implement federated learning on any device? Maybe the answer for now is still no, because for now, the companies that are implementing or integrating the system in their technologies, they've been able to put in place, the high computing devices, that have high compute power and things like that. So they are able to use federated learning on those devices. But on my device, maybe just like a little small Android, it might not be easy for me to implement. So, but how can we make it easy for us to have federated learning, being able to implement that or integrate that in simple or in non-sophisticated devices? That is still a problem. Scalability, to be able to work on any device. And like I said, device do not really need to mean our gadget. It could be an hospital or an autonomous device data center or a hospital data infrastructure. Another important challenge of federated learning, which is my research area, is security. Now, because we have different devices coming together to collaboratively learn or train a machine learning model, do we really think that these devices are honest? Maybe not. And that poses like a security issue which needs to be addressed. And that is where my own research comes in. So basically, we have to look at model poisoning attacks. What if we have dishonest or curious or adversarial clients that want to be part of a training? Because they still have something to send to the server, that's a local model, which will be aggregated to get the global model. So we could have adversarial clients amongst those that want to participate in our federated learning task. So there's a rise in model poisoning. Inference attacks could also occur if our server is not honest, is dishonest, and is kind of curious. Oh, I really want to know the data that I was using training their local model. So some expert and people are coming up with so many attack models that could be visible in the federated learning system. And some of them are saying, yeah, the server could launch an inference attack, could do like a reverse engineering of the local model and get the data. But for that, Some other people are coming up with more privacy preserving techniques in this part, not for the data, not for the local model. And then we'll talk about differential privacy, homomorphic encryption. That's like going in depth into the privacy of the local model from the client. Well, our focus now is the privacy of our data and how we can collaboratively learn, from this data to improve our AI models. So now we've talked about, I've kind of like, brought to her some of the challenges, but in a larger scale, these are not really challenges because now some of more, robust techniques are being put in place. For example, for the security part, we have a lot of defense mechanism that such that even if our server is curious and wants to launch an inference attack, it has no effect on the global model. Equally, it has no effect on the privacy of the data. Equally, if our clients, we have like adversarial client that their aim is to jeopardize the accuracy of an AI model through their learning, through their participation in the collaborative learning, there are defense mechanisms that would make sure that even if those clients poison like the model they're sending to the server for aggregation, there are mechanisms put in place that their contribution will be insignificant. As such, they are poisoning, their local model, the poison local model they are sending to the server would not have effect on the global model. So now, to bring us back to the focus of our discussion as we started, we're talking about the future of decentralized AI. Well, in some part of the world, I could say it's no longer the future, as we could clearly see Amazon, Google, Nvidia, Apple, they use federated learning now. They adopt it in improving their technologies. So for some is the future, for some is the present. So generally, the future, the present of decentralized intelligence, we have looked at it as the core essence of having to preserve privacy and having to encourage collaborative learning. Keep in mind, our focus, privacy, is a very, very big deal. We don't want all part of our lives out there just because we want to create AI models to improve our lives. No, we still want some part of our lives private. And now that's why we have decentralized intelligence. Basically, AI, artificial intelligence, is still there, but in a decentralized way. And like I said, data privacy is ensured. It gives us kind of like a level of security because I do not have my data. It's kind of have some part of your life private. Now, going forward, what people that are adopting these, decentralized AI systems are looking forward to is what we call ethical AI, basically. Now, we are saying that we are ensuring privacy, but we also want more. We want AI to be responsible, to be more safe and more fair, to be accountable as well whenever anything goes wrong. And so this is another interesting part of decentralized intelligence that is currently being talked about. Ethical AI. We want to make AI ethical. Yeah, AI is becoming private, privacy first AI. Yeah. But how about ethical? We want AI to be more accountable, to be more responsible, to be more secure in essence. We want it to be more secure. Even if we're adopting part of our lives, so 70% of our lives, or some of us, might be based on AI, but we want it to be more responsible, more accountable for flaws and errors. So that is like tending towards more of the future of AI. So, and we also want to enable more technologies to adopt AI, to adopt the decentralized AI. We want to improve to improve the awareness of it, to make it more like adoptable, easy to use, easy to implement, easy to integrate in our already in our already functional AI system. So that is one aspect of it. Like we want to enable more technologies to adopt decentralized AI because basically we want to preserve our privacy. We want to encourage collaborative learning and also gain from the future of decentralized intelligence. So I'm gonna wrap up my talk at this moment, and I've been able to take us from the journey of centralized AI and to the centralized AI, and then to the odd topic with the to the up topic, bringing together where we started from and where we are presently. And yeah, I'm gonna wrap up my talk at this point and give room for questions and clarifications. Yeah, as the case may be. Thank you.
Thank you
Thank you.
so much. Thank you so much. Adela, you go ahead.
Thank you so much, Ma. That was amazing, mind blowing, and for every part of it throughout the discussion was quite practical, and the engagement was quite interesting. So we've learned about what AI is. We also talked about the centralized part of AI. Now we're talking about what the centralized AI advantage and advantages are. Now let's talk about the advantage and the advantage, please. Can you like buttress more points? So are you saying having a centralized AI is going to impact us positively or negatively? Now, there's another question I also have for you, which says there's a big question in which you ask, should we implement decentralized AI? You talked about it, yes, but what's your take on it? Because do we have this kind of setup here in Nigeria? Because we need to talk about our home country here. Is it something we can look into and try and implement? What's your take on that, please?
Okay, so I'm gonna take the first one, the first question. So you have like, what is to, you have to clarify if centralized AI is impacting us in a negative way. Actually, it depends on where we are looking at it. The angle with which we look at it from. Generally, AI has come to make things easy for us. A lot of us depend on AI for so many things. Yeah, but looking at centralized AI, if we continue to adopt centralized AI, I mean, a lot of people still adopt centralized AI, and we are gonna jeopardize privacy. So privacy is what floors a centralized AI more. Privacy, because it does not respect privacy, so to speak, because it needs billions and tons of data for it to, to give us a functional AI system. Basically, we need, because AI is based on data. So where do we get this data from? From
Mm,
us. From
yes.
us, basically. But if privacy is a big concern to us, we want to keep most part of our life private. That's why we have to open up and embrace decentralized. Because honestly, generally, we still end up in the same spot. We end up to having the AI system we want to have, but from decentralized learning. So it doesn't. I could say when we look at bringing out all our lives to the internet, all our data, nothing is private about us. I think that is not a good thing. That
Right.
is not so. That is not so comfortable for so many people. We already have some people have most of their life online already through social media and all that. And so when we're talking about models never forget, actually, because
Mm,
we keep improving them. I mean, it might not be a big deal that you know that your data was used to train this model, fine. But that is if it is being trained localized. You still have
right.
control. But you lose control when the data has to be transferred somewhere to be trained. You do not know where your data is transferred to be trained, basically. Yeah. So
Yes.
to the
Thank you so
second,
much.
yeah, you're so very welcome. So to the second question, talking about, could you please help me remember remember that more correctly?
Yeah, so I talked about the impact of federated learning in our health system here in Nigeria. Um, so what was our take on it?
So, for us to be able to integrate federated learning, basically in our own system here in Nigeria, okay, let me start by saying that basically we all are benefiting from the federated learning system indirectly because we use smartphones. we type on our phones on our keyboard. We use Alexa, we use Siri and things like that, right? But if we want to like benefit more locally within our own community in Nigeria, would need more. In all honesty, if I'm training an LFL task, I cannot train on my PC. I have to use a GPU.
Mm.
I have to use a GPU, or sometimes it depends on how heavy the task is. I have to look for an HPCC, which is basically high performance computing center, for me to be able to run an L4 task. And that's
Right.
because I want to train like a model on different data, on local data from like 100 clients, 1,000 clients. My PC cannot do such. So looking about the requirement in our own community, Nigeria, that might be a lot for us, but it's kind of achievable because now we have cloud-based, cloud-based servers that we could kind of rent, some space, or things like that, some get allocation for our tax. But are we ready for such? Are we ready to spend as much as that to preserve the privacy of our patients? We want to build models, but we need data. Where do we get data from? From our
Mm.
so are we really ready? I mean, looking at our country, our dear country, Nigeria, I don't know. I really can't say we are ready, because even the basics, we still can't even like integrate AI in our healthcare. That's centralized AI, basically learning from or taking AI systems from other places that are already being in place. We are not adopting, like we're not so open to much technology, and that is even simpler than having to spend a lot on having high performance computing center to be able to do this federated learning task or decentralized AI task. So in all honesty, I would say it will take a lot,
Mm.
but if our country is ready for that, I am not so sure about that.
Right. Okay, thank you so much. That was quite insightful. Thank you. So some of the federated learning processes in which we learned today, how to initialize global models. We learned about distributing models to devices, device training on local data, server aggregates local models, updating global models, and request processes. We also learned about how we can apply federated learning. Generally, we have in healthcare, in finance, in IoT, and automatives. So we picked federated healthcare as a point of contact there, and which you buttress some points there, and some of the frameworks in which we've been used, or which is currently in use for federated learning. We have the Leaf, we have TensorFlow, Federated, we have Flower, and we have PySwift. So, and we also have the future. What is the future of decentralized intelligence? In summary, you mentioned some of them, which we have data privacy, which is very important. We have decentralized intelligence, we have federated learning, we have ethical AI, and we have enabling technologies and also data privacy. This was really insightful, and we are so glad to have you to give us those points. Thank you so much. Back to you.
Thank you for having me.
You're
Okay.
welcome, ma'am.
Thank you, Adela, for the short review of our presenter points. So the next agenda we'll quickly move into is a Q&A session. So you have any questions to ask, please quickly make use of the chat box so that we can read out your questions for orderliness. Okay, so I'll be starting with the first one I cited here. Okay, somebody asks, what are the tools? I already asked, what are the tools needed to implement or set up federated learning? I think you mentioned it when we were presenting, right? Do you have anything to add to that?
So basically, no. But I would just kind of like talk more about this. So basically, these are the two. So like I said, think about federated learning as machine learning, but in a decentralized way. So whatever tools you are using to, write like like to train your normal AI model, can be used for a federated learning system. However, it is better to rely more on those frameworks because they already put in place the connectivity between the client and the server, things like that. So you do not want to bother yourself about like setting up that, because that could take a lot and that could be kind of like annoying because when you can't get your client to connect to your server. However, if you really want to know more, you could do that from scratch. So these are some of like the tools. Like I said, I use Flower, and Flower was it was founded I think about 4 years ago, or 4 5 years. It's pretty new, but it's so good. It's so user friendly, and it gives results just like these other frameworks. But this is what I use. I have friends and colleagues that use other ones, but Flower works pretty good. Flower AI, it works pretty really good, and it's interesting. You see the flow of things basically, and like you see real life implementation of a federated learning system. So tools like Leave, TensorFlow Federated, PyShift, and Flower, these are like some of the tools that they're more, and in fact there are some tools that also incorporate like data privacy, like in sense of maybe adding noise to the data to make it more private, things like that. Because like I said, the server could be dishonest and might want to infer what data was used to train this model. And so, I mean, so there are also tools like that. But basically, for a starter, you could start with tools like Flower, Leave, TensorFlow Federated, and PySift.
Okay. Thank you. But a quick one. You said we should think about federated learning as a machine learning. Can this Flower tools also be used on machine learning?
So because the Flower tools are dedicated towards like a federated learning tool, in the sense that, in a machine learning, you do not need to bother yourself about client server connection, right?
Yeah.
Because you have everything on just one system, and you train, you get your model, you're able to classify and predict. But because in a federated learning setup, it is decentralized, so we have to worry about client server setup. So most of these tools, they expect a connection of at least two clients, which we do not have in machine learning, basically. So if you are going to have because you cannot have a collaboration with just one client.
Yeah, that's
You get
true.
it? So exactly. So if you want a collaboration, it has to be with a minimum of two clients, basically. So it's not going to really work for like a traditional machine learning training, rather, because but bear it in mind that what each client is doing is still machine learning. I don't know if you get the gist. What each client is doing is still machine learning. They are training, but they are training on their local data. They are training, they're still running our CNN, our DNN, the ResNet, the AlexNet. They are doing that, but on their own local data. So that's what I mean by just think about it as a machine learning system, but in a decentralized way. It's like multiple clients doing machine learning at the same time to achieve a global model for a common AI task.
Okay, thank you for that for that explanation. Let's move to the next question from Idris. Is that what is your view about the acceptability or otherwise of decentralized ledger using Bitcoin and others to avoid central banking? Do you think this is reality or mere dream?
Okay, so that opens a kind of like another chapter. When we're talking about Bitcoin, we are talking about blockchains basically, and that's part of my research. But so remember I said that for federated learning, for example, we rely on the server not for the data part, but for the modeling part of it. However, this server might not be trusted, and that brings us to an extension. Some people extend it instead of the server. We want to replace that server with a blockchain system, because the blockchain system has network of nodes we do not need a server for that in any aspect of the training. And that's what we use. That's the idea we use in the Bitcoin system, whereby we have different people connecting together, perform Bitcoin transaction, and they do not even see each other. So because we trust the transparency of the blockchain system, and that's what we use in a Bitcoin. So the question of what do I feel about, is it being realistic? Yeah, Bitcoin was it's kind of evolved in about less than maybe 5 or 6 years ago, and people like were into Bitcoin because we trust the blockchain system to be transparent and immutable. But realistically speaking, privacy is been ensured, right? The blockchain is transparent. There is no one that could delete a transaction, or that could cheat. We can't cheat ourselves in Bitcoin like that. However, however, is it really realistic to rely on this Bitcoin transaction? I would say maybe not really, because when you transact with someone on a Bitcoin platform and it fails, who do you hold accountable? Everyone is anonymous. You don't know who to hold. So basically, for the Bitcoin part of it, I do not really know much about it. But speaking of the research part based on the blockchain part, we could gain from the transparency of blockchain, of the trust of blockchain, but who do you hold? Because everyone is private, everyone is anonymous. Who do you hold when a transaction fails? Definitely not me. So I don't know. Yeah, thank you.
Okay, thank you so much for your response. So let's quickly move to the next question from the Odeyale. Firstly, appreciation, and move straight to this question. As someone in the Nigeria diaspora, I'm curious, how can this technology support better collaboration between Nigeria abroad and professionals or institutions back home? Okay. Okay, I think there is
Okay.
still more. Are there, let me scroll down. Let's see where this, okay. Can you cite where the question is? I've missed it now. Okay, are there, oh my God, I'm missing it. Okay, can you answer? Can you cite where the question is? Are there theses in the near future, possibly in 2026? We are working to create more platform like this to bring, okay, global. Okay, let's just go straight to the question.
Okay, so the question about collaboration between researchers here and and the diaspora on these technologies basically. So first I would like I said before, federated learning is not so new. Like we really can't call it like the future. It's because companies, like I showed us, are adopting it in these technologies they sell to us, or the technologies we use. But these companies, they already collaborate with researchers, maybe like me in the field, an expert and like that. But the question is, these are big companies. These are big companies. The question is, um, do we want to collaborate with these companies, or do we want to collaborate with the researchers that help drive those companies, drive their technologies? So collaborating is easy when you have, like, for example, these companies, they have those they kind of collaborate with, they have good system, they have good compute power, they have the idea, they have the knowledge, they know what they want to research on. But we on the other part, we still need to equip ourselves with some of this knowledge to know what it is, to be hands-on about it. So, for example, I have some friends that they kind of got some roles with Google, and because they had idea of the federated learning part of their research, things like that, it was easy for them to collaborate with the team that used like this systems for the technologies. So where do we find ourselves? So we need to put ourselves in a place whereby collaboration will be easy. First, by equipping ourselves with with the rightful knowledge. If I have people that want to collaborate with me on my research, you are welcome. I'm still just a researcher. So so my level of, well, the level of collaboration with me might not be so significant as having to collaborate with top, companies and top, experts in that field. But we have to start from somewhere. First, we have to know what we want to collaborate about. We have to have this idea. Is it about the security part of it, about the scalability part of it, or about the resource part, the optimization part of it? So there is room for collaboration, but at what level do you want to collaborate? I'm open to collaboration for my research basically, but for the higher levels of collaboration, maybe when we apply for roles for like as a research internship roles in those companies, yeah, maybe. But and in terms of how universities could collaborate with universities that have this research going on, that's another higher level for me. I'm just a researcher. I might not know more. I do not know much of how this collaboration happened, but from the low level of students having to collaborate with one another, yeah, that is fine. I'm open to that. I have friends that are also open to collaboration because, two heads, they say, is always better than one. Yeah, but for the university level collaboration, I'm not a top level university official, or I do not work with this tech company, with these top companies yet. So I might not be able to say much as regards that.
Okay, thank you so much. I will just quickly create a scenario. You are going to walk us through how to actually achieve this, just from a researcher
Okay.
perspective. Like a researcher that is working on federated learning, is trying to work with cancer, different data sets on cancer, reciting an example like brain, colon cancer, maybe breast cancer, and then like maybe like 3 or 4 data sets, and want to make use of, okay, like for instance, now the flower that you make use of. Can you quickly just in a simple, can you walk through the person, the stages to actually undertake in achieving that goal?
Okay. So basically, the task is cancer diagnosis, a variety of cancer diagnosis, right?
Yes.
And let me assume you as a person, or maybe like a hospital, you have this data set,
Okay.
right? But you want to simulate a federated learning system in the sense that you want to train to get a model, not because we kind of have this data in different hospitals and we want to connect. So we want to use Flower to simulate maybe 5 clients that have like 5 different data set, the same, or we have 5 clients, the same data set, but so because we are simulating, we are going to share this data set among those 5 clients. In a Flower setting, what you have to do, of course, you download Flower, you download all the libraries, all the dependencies, and most times you have like a template for the client and the server. So when you want to simulate, you actually specify. I'm sorry, I do not have that set up here, but I would try as much as possible to explain in a way would all be able to get something. So usually you have the server template, you have the client template. So the server template is usually one for the clients because we want to simulate 100 clients. You cannot specify the number of clients you want to simulate. And because we are simulating, we have one data set for brain, breast cancer, lung cancer, and all that. You could shard, like distribute or partition this data set amongst the 5 clients. Flower has a way of doing that. It shares those data set. Let's say you have like 1,000 data set, rows or record in a data set. And that's like we're sharing this with 5 clients, like 200 for each client. That is like, let's assume the data set is balanced. So we share them with these 5 clients, and the server initializes the global model. So everything starts from the server. It initializes the global model, and we tell it, oh, we're going to use 5 clients for this training. And so it's waits for, you could have a setting to wait for the 5 clients to start beginning to join, or a minimum of 2 clients, for example, because that's the minimum in most frameworks. So as soon as the server sees that 2 clients are connected, then it generates an initial, or it's randomized an initial global model, or it could use a pre-trained model if we want to improve the model, for instance. And so it distributes this model to these 5 clients. And this model could be a CNN that has like 3 layers, and that's like the ReLU activation layer, and it has like the output layer of maybe 5 classes of breast cancer, brain cancer, or lung cancer, like that. So this model goes to each of these 5 clients. It broadcasts it to these 5 clients, all still on the Flower framework. And this client, upon receiving this initial model, they have their own partition data set of 200, maybe cancer images or something like that. Then the train, our normal machine learning training, they generate the local model, and they train like simultaneously. Yeah. So they train simultaneously, and they send the local model they generate from this training back to the server. So in Flower, how this happen, they kind of happen in like classes and in functions. So the training function for each client, it will call it will receive the initial model, but it will also initialize its own data, the train, and after training, then the send the results of the training as like as the return from a function, for example. It returns it, and the function that calls it, that sends it the initial global model, it takes the local model generated from each client as a return statement and send it back to the server. So when server gets this, it's collected as a form of tuple. Now this is data structure, tuple, things like that. Tuple, list, class, list, and things like that. So it takes them as a tuple and to the server in case of Flower, and it's kind of extracts each client's weight and then aggregates the weights. So there are different techniques of aggregation. The traditional, we call it federated average. And what it does, basically, we have 5 clients. And to mention, each client would also send the number of samples it's used to train the model. It doesn't send the sample, the data. For example, it sends 200, comma, the array of the model weight to the server. Then the server extracts this and aggregates the 5 model weights from 5 clients, and it aggregates them with the total number, that's 1,000. Not the total number of clients now, it aggregates it with the total number of samples. Then it gets the aggregated global model. Let's say for round 1, let's say we're going to do 10 rounds for us to arrive at a convergence, or for us to handle the learning tasks. So for round 2, the server again sends this aggregated global model to this client. They repeat the same process, the train, generate the local model from the training of round 2 and sends back to the server. So this back and forth goes on onto the 10th round, because we want to do for 10th round, onto the 10th round, and then after the 10th round, that's the training ends in Flower automatically, because we set the number of rounds, we set the number of clients. We also set the minimum number of clients you want for the task. Though we have five clients, but what happens when perhaps one of the clients drops out of the training and say, "Oh, I'm no longer interested"? That should not stop the federated learning system. So we must specify the minimum number of clients that are required, or that is required for the process to keep going on. Bear in mind the minimum number of clients for a collaboration. You can't collaborate with one client, it's 2. But you could place your minimum, even if you have 5 clients participating in the task, your minimum of clients for the server to aggregate could be 3. That means once the server receives 3 local model, it could aggregate and continue the learning process. So I hope I've been able to explain in a way that we would understand how it works on framework. So basically that's how it works on framework. It's not a complex scenario. It's just like instead of having one client doing something, we simulate multiple clients, but they still train the same model.
Thank you so much for tonight. It was very insightful, it was very enlightening, and it was very impactful. Thank you for creating a beautiful scenario. It was so amazing. Thank you so much. On behalf of Womwn in AI in Nigeria, we want to say a big thank you to Madam Rukayat Olapo Jurie. Thank you so much. I think in the absence of any question, because of time, we need to round up. And please, we would love to have your slide so that we can share with everybody also. So I believe you will share that one with us so that we can share it. So thank you so much. We want to call it a day now. Till next time, we'll be calling you back, right? So we're actually planning a workshop. So as many that show interest in actually knowing more about it, so we are going to send a poll. We are organizing a workshop very soon. So anybody that wants to know more about federated learning, you want to know more about Flower, kindly join that poll so that we can bring our Madam Rukayat back. All this scenario, she will now come and show us in real time. That's what she will come and do for us. So thank you so much on behalf of all the women in Nigeria. We want to say a big thank you to you. Dr. Shekinat, is Dr. Shekinat online? As we round up, is Dr. Shekinat online, Adiola? Okay, I think he's not online. That's our host for today. She has been having a little bit network issue. So thank you so much. You want to call it a day? Thank you so much, everyone, for joining us. Thank you to our amazing speaker. Thank you so much, everyone. So we meet again. Watch out for our podcast that is coming up. That's this next month. It's going to be very interesting one. Make sure you don't miss it. We'll be live on LinkedIn again June, first week or second week in June. So we'll be sending the flyer out. So just keep following us on our LinkedIn and keep following us on our Twitter. Thank you so much for joining us, everyone, and have a lovely night rest, everybody.
Thank you for having me.
So much.
Blessings to everyone. USA. Thank you.
Bye.
Bye.